Hello, welcome back to another episode of the Reliability Gang podcast. I'm here with my right-hand man, Will. How are you keeping, buddy?
Good, thank you very much.
We are back with another podcast, and do you know what? This week has been a lot of thought process for me, and I'm thinking, what are we going to do a podcast on? Because it's been a while since we've been doing this. We had Main Tech. It's just been, I'll be honest, like the response from Main Tech was incredible. It was just incredible. Like literally, I'm still obviously in meetings from that period, and we're still having discovery calls and all sorts of great stuff, which is amazing. But as well, that means that the focus has shifted a little bit. But this week, I've just been really kind of thinking about how do we pick this back up? It's been a while since we've done a podcast. Where are we at with everything? And with a lot of the calls and the sales calls that I'm having, it's very interesting because obviously when you do have some of these sales calls from Main Tech, they are talking to other providers as well. Because obviously you're not the only one at Main Tech. There's other people that do what we do and all the rest of it, and they're there and they're having discussions, and they're usually trying to obviously have a discovery who is the best provider for them with their aims and goals and everything. So a lot of these meetings that I've noticed in terms of strategy, especially vibration analysis strategy, in terms of what they're trying to suggest, is that I'm seeing a lot of kind of wireless sensor options being thrown across.
A lot more popular now.
A lot more popular in what we're doing. And again, with this year, our strategy for that has changed massively as well with the Sparrow. We've got a lot of demo kits going out to even some of these customers as well. But as well, what we're trying to also do is kind of, obviously it's great to sell some of these sensors and to monitor things, but we as a business need to also understand the reason why you'd want to go for that option, if that makes sense.
Yep. Ties in nice. I did a LinkedIn post recently all about the why. Why do we put a Sparrow on? Why would we choose an MVX? And I think that's what we're going to cover today.
Yeah, definitely. It's going to be an interesting discussion because as well, in perfect timing, Will's role has changed. So this is probably going to be the reveal, shall we say. But obviously, Will, as you know, has been dealing with the operations of the business for the last 2-3 years, I believe, and now we're moving into a different age. We understand how important that the technical element of wireless sensors, Aquem vision, the data reporting processes through kind of like refine AI as well in terms of how do we utilize that for the business. Will's role is now turned into a technical director role. So this is a perfect time to talk about this because me and him have had a lot of discussions. Because generally within Maintain, my kind of role is looking at the future, like where's the business going to go? What do we need to do now to ensure 5 years from now that we're in the right position where the industry is going to be? That's always really difficult when we're moving fast, but culture's not moving with it. Does that make sense? Because we're like, we need to be prepared. We need to have all these processes available if we need to do a bit of 4.0. But the problem is when we're getting that stuff ready, we're talking to our customers and in and around us, and some of them not even doing condition monitoring to begin with. So this is where I think this conversation is going to add so much value in the sense of if you're a customer that haven't got any kind of condition monitoring or vibration analysis, how would you set up that strategy? How will we define where you would put some of these wireless sensors? Because there's some customers I'm talking to, they've not even had any handheld. They've not had any version of it. And they're now obviously coming into this world and they're having discussions about wireless sensors. But I think what me and Will have to do now is give you guys like almost what are the stages and why would we put online sensors on? Where is the best strategy for vibration analysis and the most cost-effective one as well?
Yeah.
Because let's be honest, putting a sensor on every single asset within a plant that has 500 assets is not going to be cheap. And is it necessarily going to give you the value that having a guy going around and doing some good observations and taking data is going to be? So today's podcast is going to be vibration analysis strategy. So I'm going to let Will talk a little bit about kind of failure mode. Again, taps into reliability again, or a lot of this does. And I think sometimes if you haven't had the reliability studies done on the plant to understand criticality, to understand how something can fail, this task can be a lot more difficult, kind of, Will.
Yeah. We have to kind of like take a few steps back a bit because the whole idea of doing condition monitoring is because at some point down the line, somebody generally has said that we need to look at doing a condition-based maintenance approach. So a lot of maintenance in plants who don't do condition monitoring are going to be reacting to their maintenance. So they're in a reactive maintenance state, or they're going to be changing it every so many hours just because they want to. And I think now there's a general consensus that everyone understands that doing condition-based maintenance is a good thing to do. Saves money and only does the maintenance when we need to. So initially, the whole idea of doing condition-based maintenance and vibration analysis is that vibration analysis is a very effective condition monitoring technology that can detect a wide range of failure modes very effectively. And generally the main ones that we're concerned about, bearing defect.
Yeah, the ones that
you
are going
know,
to stop you in your tracks generally. This, I think, why vibration analysis probably is the most popular.
yeah,
Is it because it can identify the things that are going to, cause your plant to stop?
yeah. And in reality, and generally speaking, what we'd like to do is we'd like to go to the plant and we'd like to do the criticality assessment and really understand the criticality of the machines. And we'd like to maybe do a FAMICA or do RCM to really understand what maintenance needs to be done based on the ways that potential machine could fail. But not everyone has that tool set available to them or the experience. And so, or necessarily initially the time, because all of that takes quite a lot of time, which is why we often find that vibration analysis, especially in plants that don't do anything, can be a great just let's get going and doing something
Yeah.
to get some buy-in as well about the bigger picture of reliability.
And I think this is why most plants, when they're having failures and it's causing quite a lot of chaos within the plant, this is why a lot of plants do look to do some condition-based maintenance, vibration analysis off the off before they've done them
Yeah.
studies.
And
It just makes it a little bit more difficult to understand what strategy to apply. But this is where maintain can help in the sense that we don't do a full-blown criticality assessment, a
no,
full-blown FAMICA and all of these assets. But from our experience of obviously doing this for years and years and years, a lot of the machinery that we're monitoring in terms of these plants are very similar to the places that we have
and
done these studies with.
and that's the important bit to take from that as well, is that we are maintain reliability. We're reliability engineers, so that our experience and expertise comes in at not just looking at how we're going to monitor that plant with vibration analysis. We're not just vibration data collectors. We're doing the mini FAMICA in our
We
head.
already know, don't we? Before, again, don't get me wrong, there's some real complex machinery that is going to require that, if that makes sense,
Yep.
when you're looking at the
The
plant.
hidden failures that you're not really sure
Yeah,
about.
but I mean, the majority of most plants, when you've got, the common rotating machinery,
Gearboxes.
motors, fans, gearboxes that, generally run a process of a plant, we already kind of know what is important
Yep.
or not. And I think once we've kind of had a look at that criticality and we've kind of done our own kind of assessment and we've had a good conversation with the customer, quite quickly we can get an idea of the assets that probably need to be in this program. The beautiful thing about vibration analysis and handheld vibration analysis, and we know this now more than ever from moving away from, older collectors to the Echo and Falcon, is that we can, on a high-speed piece of equipment, take one reading that will have 3 axes of vibration and it will cover multiple different failure modes in terms of frequency range in 9 seconds for one bearing.
Yeah.
So if you can imagine an asset, a fan, for example, you're probably going to have 4 points on that fan, 2 on the motor, 1 for each fan bearing. If you're taking 9 seconds per reading, you are literally probably taking data on that asset in under 1 minute, if it is running and it is obviously in the same process conditions.
And you have to think as well with that handheld data collection, which or portable data collection, within that 1 minute that you've data collected, let's be extensive and say in a minute and a half.
Yeah,
Within that
let's
minute
add
and a
some
half,
more time on
let's
that.
just add some more time. So within a minute and a half, an engineer has gone to that machine. They've probably felt the machine, assessed how hot it is. They've probably felt and assessed how much it's vibrating just with their hand. They've tested it with the data collector. They've screened the data. They've understood if it's okay. If it's okay, they've left it. If it's not, they've made notes on it. And they've already done the pre-analysis before anything's been done. And that's all been done in a minute and a half. And that is why portable data collection, the visual aspect of it, there are failure modes, belts, that can wear that don't necessarily enough to cause the vibration.
And this is the other thing as well. If a plant hasn't, and quite likely, if we come in to do condition monitoring and they haven't done the initial part of criticality, failure mode analysis, then how do they know that their PMs are valuable? Probably not valuable in that sense as well. So that also means is like, again, the wireless sensor model, assumes that can detect the defects that vibration analysis can pick up, right? If we haven't done proper failure mode analysis on that particular asset and understood, well, what about the belts?
Yep.
What about all the things that VA can't pick up on? The other
You're gonna
failure
miss
modes,
them.
you're going to miss them. And this is the thing with, ideally, if you've done that properly and you've got good PMs and people on plant that are available to do them things, then maybe you can put a wireless system on that and
100%.
and know that it's going to pick up all the failure modes because you've got the other ones covered. The problem is that we're seeing in most of this industry that people are coming in
Blanket approach.
putting sensors on everything. They've not even asked the customer, well, what other
Well,
plan
we
maintenance
went
have you
down
got
to
on these
that
assets?
customer down in Devon who are now we've been working with quite a long time, and we're putting the AWS sensors on,
Yeah,
and they put it on a bearing that was what, 10 RPM
not
maybe.
even that. I think it was a cooker bearing.
It was on like
It was, yeah.
a pan cooker.
A rotary can steam cooker, right? And they're putting these sensors on assets that are moving less than nearly 10 RPM. There's no way in
Even portable
hell.
data collection is going to challenge.
Exactly. You will. How long would you have to stand there to get the revolutions? This is a
Well,
complete.
a minute if it's doing 10 RPM
Well,
at
exactly.
least.
You're standing there for a minute, and don't get me wrong. I remember when I was my old company. We were testing these cookers. We were testing these cookers for about 4 minutes on one reading.
Yeah.
A long time waveform. To be fair, ultrasound's probably a better method of technique and measuring now, and we do that as well in terms of just measuring for them long periods of time. But again, this is another kind of real concern in the industry that they're trying to blanket approach, and they're not even looking at even the speed. I mean, that's just basics.
I mean,
And that is scary. Do you know what I mean? That we're coming across that nowadays because this is something that we're also concerned with because, how many times have we seen and we've gone to site and they've got, little sensors and they're not even in the right position. Did you know what I mean? Like, let alone having the frequency range to pick up the defect. And this is where there's a clear misunderstanding of a lot of data companies selling sensors that have no reliability experience whatsoever, or mechanical experience to understand how things can fail. Do you know what I mean? And it is worrying for us when we see this because how many companies have already invested a lot of money in this and gone down a bit of a road and bit of a route with it, almost to have to come back to square one to then do the reevaluation process, because we wouldn't suggest you put all of these out until we've done the proper studies to understand why you need them and where you need them.
Yeah, because a wireless sensor, a continuous monitoring system like the MVX or the wireless sensor like the Sparrow or any other on the market doesn't make you detect failure modes any better.
No, it doesn't. No,
it doesn't. It doesn't mean if I put a wireless sensor on, I can now detect this and I couldn't before portable data collection. The only difference between these two sensors is that they can collect data more regularly.
100%. And also we have to consider. So I'll give you a really good, perfect example here with our kind of wireless sensor or online sensor solutions that are great, by the way, and it covers a wide range. And this allows us as well to select the right sensor depending on the machine as well. So we obviously use the Sparrow, okay? Still a very good sensor, right? 5 kilohertz frequency range, isn't it? So
yeah, so the Sparrow is a MEMS-based sensor. So any sensor on the market that is of kind of a smaller form factor, generally is going to be a MEMS-based sensor.
Yeah.
What does that mean? Just so the guys understand.
Basically, throughout all of time, piezoelectric sensing was always a way to do vibration analysis. MEMS sensor is more of a chipboard that has kind of more electronical chips in there. It doesn't have the piezoelectric element that usually is able to pick up the higher frequency ranges. But technology is improving, guys. And again, the more that we actually advance in this tech, the better these sensors are getting. We've tested the frequency ranges on these sensors.
Very good.
And they're very good.
Clean data as well.
Very clean. And again, I was a bit of a skeptic at the start of all
when
of
we
this.
say clean data as well, we just mean the data's not got a lot of noise in it.
Yeah,
Signals
it looks nice. You can see the peaks, and you can get the separation in terms of like frequency ranges and frequency detection. But yeah, that sensor, very good. Obviously cheaper as well, because obviously, to manufacture piezoelectric sensors is not cheap. Do you know what I mean? It costs money. And it still can give you 3 axes of, readings as well.
And temperature.
And temperature as well. So very handy metrics and measurements to know. So that's kind of the cheaper option. Then you've got the Eagle. It's still a wireless sensor option, okay? But I would say the Eagle's more designed to be able to replicate the handheld vibration measurements that we take, but give you more of it. if that makes
So you
sense.
don't, with the piezoelectric sensor, the way to think about the difference between the Eagle and Sparrow, other than price point, is that frequency range basically means that the higher the frequency range, the most simplest way of thinking about it, high frequency range, generally we can detect the defect earlier.
Yeah.
That's the easiest. It's not that simple, but it's the easiest way to think
Yeah.
about it, because when a bearing, let's just pick that as a defect, first establishes itself, is going to create high frequency vibration that is going to start in the high frequency end of the spectrum, and as the defect develops and gets further down, we're going to start seeing that increase in amplitude lower down the spectrum.
100%.
So your
Yeah.
piezoelectric, we can be a lot earlier with its detection, but when we say earlier, we're talking like generally months.
Yeah, because
like
if you understand that bearing defect where it comes from, what we're actually trying to see is the harmonic content of that, which will be at higher frequencies.
Yeah.
Okay. So when we see the harmonic content, right, we're looking at higher frequency ranges to first identify that is available. So obviously, the lower the frequency range a sensor goes down, you're not going to pick up the harmonic content of the defects, right, until it obviously it appears within its frequency range. Okay. So again, the Eagle, great for looking at like poor lubrication and stuff like that, because it can measure up to, is it 20 kilohertz? It's exactly the same as our Falcons, which is incredible. So imagine having a portable data collector, but taking data whenever you need it to. The idea of that is, though, you don't take probably as much as you would on the Sparrow, because you don't want to drain the battery because it's a piezoelectric. So you're really looking at 1 or 2 readings per day. But then think about that, right? Say if you're taking a reading per month on that asset, right? That's 12 readings per year. If you start taking a reading a day, well, you're getting 30 readings per month now. So now you can now see the scalability of even taking 1 or 2 readings per day. It really gives you that understanding what's going on a lot sooner, if that makes sense as well.
And that's the idea. Like both these systems, Sparrow, Eagle, MVX, all they're doing is allowing us to capture more data than what we would do traditionally with handheld equipment.
Yeah.
Sparrow, we can, depending on how quickly you want to drain the battery, you might set it to 1 measurement a day. You might do something similar for the Eagle. MVX, we're looking at the machine every 80 milliseconds. It's as close to continuous as possible.
It is a wired system that's
powered,
and piezoelectric as well, and as well can integrate with a lot of different systems and grab information and display it as well. A very unique system. But again, this system is really, I'll be honest, is looking for different process parameters, really tricky assets to monitor. So whenever we go do a handheld monitoring on an agitator, for example, well, 1 month it might be making product B that is this viscous, different load, different speed. It might range through speeds in just even making that one product.
Last night I was talking with Aquam about example on a CNC machine we're now using, and what we can now start to do is we can take the information from the CNC machine into the MVX, so it knows what tool it is using, because the vibration is going to be
process again. So when you're then trying to do handheld VA on real high process driven equipment, I'll be honest, it's a very difficult task, because if you can't trend effectively, you can't understand what's good when it should be running, and you can't deviate from that through different kind of measurement parameters.
The MVX is used so much on wind turbines, because a portable data or a vibration analysis worst nightmare is when speed changes, load changes,
load,
complex gearboxes. Wind turbines have planetary gearboxes.
And that's the thing. When we're doing vibration analysis, everybody knows it's so dependent on what speed that we're measuring. Because if we don't know the shaft speed, then how do we know the fault frequencies that exist from that? And if you get a constant machine that's constantly ramping up and down, you're never ever going to be able to test that machine at the same conditions each time. So the idea is, if you had a tacho and a shaft, you can tell the MVX, okay, when it hits this speed and this condition, I want you to take data then. So then when we do look at our data, we can say, we've got stable conditions to trend against. But again, majority of equipment, 80% of equipment does not run that way on site. Usually a high percentage of equipment or rotating machinery, and quote me if I'm wrong, do you know what I mean? Your plant might be completely different. You might have loads of that process stuff, you know what I mean? Which is okay, because we can still monitor it. It's just going to be able to be a bit more difficult. But a lot of the machines that we're looking at will run
fairly standardly.
Up to a certain point, it will run like that, and it will run at the same conditions, similar loads. Don't get me wrong, loads may be a little bit different, right? But generally the same every time it runs, which means we have stable conditions for it to run, which means that handheld data collection actually
It's still
dependent,
very effective.
yeah, is very effective. But then we now have to define the frequency of when we come. Okay, to give you an idea of how much cheaper handheld vibration analysis is, because it is you know, because the reason why it's cheaper is because how long it takes to collect the data is very quickly. So within a day, if you've got assets that are running predominantly all the time, okay, and you're not going to have this, you're going to have a percentage of assets that are difficult to collect, but we've got solutions for that as well. This is another why of why we can use these other systems, because there's gaps in the data sometimes that we do need to make sure we've got. But generally, we can collect up to 100 assets a day if it is running and it, you know,
Consistently.
and it's consistently going. Think of that 100 assets that you've got in that one day. Do you know what I mean? That you've got
And how
data
many
on.
sensors you'd have to put on if you were going to.
So let's do a case study, right? Real quick one. We'll just talk it out. We'll talk it out here, right? So you get 100 assets, okay? In general, most assets will have a motor that runs or drives something, okay? So it might be a motor that drives a fan, motor that drives a pump. So if we average 4 points per asset, which I think is a good average, okay, that is 400 points if you're talking about 100 assets, okay? 400 points, okay, right, is what you're going to have to duplicate to be able to get the same amount of data what you're going to be able to get from a handheld vibration program. Okay, say for example, do a little bit of quick maths,
Even if
right?
you simplified it and said the sensor cost would have to be cheaper than £5 a sensor to make it worthwhile.
It would, yeah. So say for example, right? Just example. £350 for a MEMS base sensor, or
Yeah.
say 400 quid, right? It's a good average, okay, between most of
On
the
the
competitors
market.
on the market, right? If we times that by 400, because that's 400 points that we need to monitor, that is going to be £160,000 on the off. We're not even talking analysis
Just in
now.
hardware.
That is just the hardware, and that's a lower cost sensor, okay, to be able to install on your factory, okay? If, for example, say VA, we'll do an average rate. I'm not, you know, giving away rates anyway. Say, for example, a day rate is £1,000, right? Just picking out of the sky, okay? Within that £1,000, £160,000, right? Divide that by the day rate. That's 160 days vibration analysis just for the hardware.
Divide that by 12.
Divide that by 12, 13.
So it's 13 years as VA.
13 years just to be able to cover for the hardware. This is why, guys, it is not a wise strategy to go out and try to put a sensor on absolutely every asset. It's not viable when you don't need to. Does that make sense? And I'll say that with my chest, because there's so many companies out there right now that are just trying to blanket approach things. So 4.0, yeah, let's be the digital. Don't get me wrong, we've got incredible systems. Aquam have created some incredible systems. Do you know what I mean? Amazing systems. But remember, we've got to apply the right technique for the right asset in the most cost-effective way.
I think that's
Okay?
then to understand really about the frequency aspect.
Yeah, and this is where I'm going to Will to talk about the frequency, because obviously this now does look into the reliability element, and we are experts within this. So now we'll talk about, okay, say for example, we've made our point, okay, it's obviously a lot cheaper to do handheld VA, and when we do it, it's highly effective because we're using high frequency measurements and we're doing some observations. How do we define the frequency of how that is done on a standard machine?
So we've spoke about already how Sparrow, Eagle, and MVX, basically the main benefits of these, other than the Eagle and the MVX, that also are piezoelectric. These systems allow us to collect data more frequently and allow us to collect data without an actual person being there, which we'll come on to in a bit why that's quite useful.
Yes.
And so the idea of having more frequency is that when we understand our failure modes, the whole reason, as standard in the industry, data collection generally is every month, usually.
That is the general status quo. Yeah.
Sometimes on some machines, if the criticality isn't quite as high as others, you might be able to get away with a bi-monthly reading. But that is the minimum, because anything less than that, you're really struggling with your trends.
High risk as well.
High risk. So the whole point of setting frequency, though, is typically, now you're not always going to have this reliability data to hand. So you have to use people with experience and expertise. And that's where the industry has set this monthly measurement, because through data collecting over many years, we've established that on most failure modes, a month should be sufficient, but it's determined generally from the P to F curve. So your point of potential failure, so if you're monitoring a bearing defect, and you've got a machine and maybe it's a bit specialized, and you understand that from the point of a potential defect being initiated to the point of it actually failing, if you've got that information, or we can maybe look at ways of understanding it, if that failure frequency, let's say, is 2 months, then we should be collecting the data at half that interval.
So that's where you get the monthly data intervals as
Yeah.
well. And generally, I'd say, that's a great point to make as well, Will, because when we are choosing that frequency strategy, a lot of people will just say, oh, we'll do a day a month because that's what the standard is. This is where we also need to consider some assets on site that may be a little bit faster in operation. So
Yeah.
I'll give you an example, okay? If you've got a 2-pole mower that's running a grinder, for example,
Or a screw compressor.
or a screw compressor, gas compressor, generally these will run at high speed intervals, okay? This is where our monthly readings, you now may consider saying, right, we need to now take more data on these assets. And what you could say is, and what probably still would be cheaper, is by just having another visit in between, because again, it's going to reduce that time, okay? As long as the operating conditions are not deviating and all the rest of it. Or then you could consider, say that could be a little bit overkill to send an engineer out. Then I would then consider the few assets that are running higher speed, that are highly critical to the business. That's when you would start to consider some online system.
You then have also, you can look at it and go, okay, overkill sending an engineer every month, maybe. Okay, even if in the P2F, even if we look at, let's pick this gas compressor and we say, well, from the point of potential failure, we might be looking at a week or two, right? You're going to want to measure it maybe every week or something like that. But you've also got, with an MVX system where you're measuring it every 80 milliseconds, you might say, oh, that's overkill. But you've also got that safety factor. You've got that reassurance.
You've got the peace of mind as well. And that peace of mind sometimes, and that's the thing a lot of the time, is what a lot of people say as well when we're doing kind of vibration analysis, like, oh, well, it's been good for ages, why do we need to do it? Because you're paying for the fact to know that it's okay as well. That's good information to have. But this is the other thing as well, and this is the thing for us with our strategy when we look at it, right? When we come to site, we want to ascertain, where can we get a mixture of all of these things? So handheld VA when we come to site, and we get the good observational stuff as well. Then we can start to look at some of the assets as well. And again, let's look at the reasons of why you'd want to put an online system on, and what would be our criteria for selecting the right.
Maybe we should do that for each one.
Let's do it for each one.
So MVX, continuous data monitoring. Okay.
Let's look at it. This is the hierarchy. So we're looking at the creme de la creme online system now. That it's a powered system. It allows us not to worry about battery changes in terms of sensors. It still uses piezoelectric sensors as well. We can use dual output sensors as well. We can look at obviously temperature sensors as well, and obviously everything can go into this. There's no limitations with this system.
Maybe we could do a bit of a backwards and forwards of our ideas. Why we'd put an MVX for each one. So I'll do the first one.
Yeah, you go.
Okay. Varying speed or load is why I would consider putting potentially an MVX on, because we can input the speed and load into the MVX so it collects data all the time.
Perfect. Health and safety. So if you've got an asset like a fan, a big fan, where there's high likelihood there's going to be, there could be a change very quickly in fault. Say, for example, imbalance, right? Say, for example, you've got a fan, and generally it may run and it may not. It might ramp up and ramp down. We've had that of a few fans as well. But usually, say if there's a shock imbalance or something comes off the impeller and it goes out through the roof in terms of vibration, we want to know now. We don't want to wait until next month, because the failure then, the risk of failure of that asset multiplies dramatically. So you've got to also look at them failure modes and what could be the real risky failure modes that could cause that asset to completely spiral out of control. So health and safety, a real good one for me as well.
Another one. Okay. Machines where the failure modes can happen very rapidly.
Yeah.
So things where something can happen and it can deteriorate very quickly, and we may need the system to be able to identify that a lot earlier. So things like that.
Yeah, definitely. So MVX is looking at real high process parameters.
it's live. It's as
It's
live as
live
live can
system.
get.
And,
So
and another example is like an agitator. So these agitators for us have been a right pain to be able to monitor, okay? Because every time we go to site, it might be running a different product, different speed, different load, doing all sorts of crazy process parameters. An MVX system will be able to set that up to be able to
yeah,
take data at the same similar loads, same speed, so we can get a good, reliable
yeah.
trend, so we can still analyze this data.
Machines that start and stop very rapidly.
Yeah.
So
It's so difficult to you put your sensor on
we're doing it
and
on a
start and stop
CNC
before you
machine
even,
now.
yeah,
You know, your
CNC machine.
CNC is going to go hit, then there,
Yeah.
over to there. So we need to be able to trigger that data very quickly.
So you are looking at very high critical machines
Yeah,
that could have post
or complex machines
or complex machinery that are difficult to be able to get
with
through handheld and even wireless. Because
yeah,
you could say, well, why don't you just put a wireless system on there? But let's, for example, say you put a Sparrow on it. Well,
yeah.
a Sparrow window in terms of data collection time is what, probably 0.4 seconds that's going
You
to
have to
take.
think the best
So,
way.
and as well with the Sparrow, you can't obviously trigger that reading to start.
Yeah.
It will just every X amount of time it will take
Just
a
wake
reading.
up.
It
Yeah.
will just wake up. So you might be missing the reading every single time trying to wake.
Yeah.
The likelihood of getting that information or data is very low. Let's be honest. So let's go to Eagle now. Okay, so Eagle is really what you're looking at is your data collector being able to take data a lot more regularly. Okay. So with this particular application, I would not suggest it for high process parameter changes as well, because it's not designed to be able to do that. Because remember, the Eagle really is designed, I'll be honest, to take a reading a day.
Yeah.
If you clock it to take more readings than that, is you're going to vastly drain the battery. Because remember, it is a wireless sensor and we're taking high resolution piezoelectric data. So you can't trigger that to take 10 readings a day because you are going to drain your battery. You know what I mean?
Even once a day is going to be somewhat extenuous on the system, depending on all the measurements that you've got set up on the Eagle.
All depends on what you're taking as well.
This is where it comes in as to really where the Eagle's kind of pitched at and designed for, which is one of the best applications for Eagle is a hazardous environment that you can't go into.
Because the one thing about the Eagle, this is a zone naught.
Yeah.
It's a zone naught EX. So perfect opportunity of where you probably don't want a guide to go into because of the health and safety element of it, but you're still able to take data every single day. Do you know what I mean? You know, and get that decent trend over time as well. So it then takes the risk away from an engineer going into that area or hazardous area. But still, I mean, again, usually if assets are in these hazardous areas, they're going to be fairly critical, aren't they?
Yep.
To health, safety, and production and environment probably as well.
Yeah, you may not want your engineer going there, but that Eagle sensor is going to give you, especially for when you maybe have complex machines that are still continuous in their running speed, so their load is the same, but or you need that earlier indication. So say you maybe have got it, maybe it is a gas compressor, but the load doesn't change, the speed doesn't change, it's always running
in this operation.
You know, you want to be, that's a very critical asset to the plant. It might be in an area that's really hard to get to or poor access, and that would be an ideal candidate.
We are using, again, within our industry, I'm looking at the biogas industry, we are looking at MVX systems and Eagles to be able to counteract both, because obviously they're hazardous environments. Depending on the strategy, it's either one of them or handheld data collection with an EX data collector as well.
Yeah.
So Sparrows, obviously, again, these are the beautiful little sensors as well. They are, because what we can do as well now is change a battery very quickly, which means now we can take a little bit more data than what we are looking at with, you know, the Eagles. Okay. So that means we can get a better picture of what happens within the day. With that, obviously, the more you take data, the more it's going to drain the battery and the quicker you're going to have to change it. But because that now has become a lot cheaper and a lot easier to do, now that option is now on the table. But as well, what it does allow us to do is able to be able to, again, it's a lot cheaper sensor to look at the lesser critical assets, still important, but as well gives a good idea what's happening with them as well. So a good application use case for me would be if we're doing monthly VA and we're finding that you've got, you know, you look at your data and all the assets we're testing, we find that E102, for example, we haven't able to collect data on that in the last 3 months. And that's quite concerning because it's fairly important to the plant. But every time we've come to site, unfortunately, it's not been running. It's not going. It's not running. So we find it quite difficult to get a steady trend with our VA, which then creates a longer gap of data, which then creates higher risk for that asset as well, because we don't know what the condition of that asset is. This is where I see Sparrows coming into action, okay? You don't necessarily want to put high piezoelectric sensors on these assets because it could just be a gearbox or a small motor gearbox, and the cost of that is going to still be too much, right? And not only that, you still should only take one reading per day with that. It's really designed for assets that run all the time. What you can do with the Sparrow is take more data within the day. You might get a bit of missed data, but it's going to be able to detect when it is running, and you're going to be able to get that information to fill in the trends on them assets that are really difficult because of process, all right? Again, access, okay? You might have an axial fan up, I don't know, up out the way, hard to get to, out of sight, out of mind. Do you know what I mean? Sparrows for these assets are inaccessible now. I think are going to supersede the fixed sensor model. So back in the day, we'd just wire fixed sensors to it to go to our data collector machine. But now the cost of these sensors is a lot cheaper. Why not put a sensor on, so we can actually start to get more data on it as well? Seems to me to make more sense in that option as well. But remember, even if you put fixed sensors on this, it's still relying on it running. So you still, you know, if it is a process-driven application, well, you might not get data on it anyway.
And Sparrow as well is a great option for plants that are looking to go down a digitalization approach, but they need to understand it's okay to be in a position to say, hey, we want to digitalize the plant, but it's important to understand the why you want to digitalize the plant, because digitalizing the plant isn't going to make you detect the defect any necessarily more effectively. What it's going to allow you to do, though, is going to allow you to be a lot more predictable when the defect becomes apparent.
Yeah, and you say digitalize the plant, that doesn't mean that handheld is not digitalizing your process, because Nest Vision allows us to see all of the data that we collect in one place, which is digitalizing your process. Doesn't matter how we take that data, whether it comes from a wireless sensor or we're doing it, it still allows you to see your health conditions of all of your assets just in different ways. So when we talk about site digitalization, that's still a form of it. It doesn't have to be constantly monitored by a sensor to be digitalized. Do you know what I mean? We're still driving data into the same place, but we're just picking the right frequencies, the right strategies, the right techniques to be able to mitigate the failure modes in the most effective way, in the most cost-effective way. Because everybody knows, even that 100 asset model that we just went over there, a lot of sites have more than 100 assets. So you have to now remember the cost of being able to put a sensor on everything without really knowing the reason why is not the right strategy, guys. The right strategy is looking at the whole thing, then having a good mixture of different things depending as well on the failure modes of your equipment. So if we do identify the failure modes are difficult to detect, we'll put a few MVX systems on really high critical.
We can't afford to lose.
We can't afford to lose them assets, and they might be moving in different ways. So we have to make sure we monitor that way. Then it's having a look at the next stage down, saying, right, we've got a few hard to access machines, highly important. Toxic environments as well. So we don't want anyone going up there either. So great, perfect. Well, let's put some Eagles on these. We've got covered there. We've ticked all the boxes there. Then we might go a step down and start to look at some other things that are a little bit inaccessible, hard to get to, not as critical, and maybe not in a toxic environment. But then we still can then deploy that Sparrow sensor kind of
important
option
to the site still, but not at the point where it's important enough that you kind of want a bit more than a monthly data. You kind of want a bit of visualization of what's going on, but it's not to the point that you want to put, you know, a 10,000-15,000 pound MVX system on.
Or you know, with the Eagle sensors, the Eagle sensors are a lot more because you've got, you know, it's a lot more high. Yeah, it's a high-tech sensor, really. It's a great sensor, but you're going to have to pay for what you get for. But then when looking below that, if you haven't got that criteria for any why, then have an engineer on site. It's accessible. It's easy to get to. The failure modes don't allow it to fail within that period that you've said with the P&F curve. Handheld VA is going to be extremely vital, and it's going to be a very important strategy still to be able to get the bulk of the data on a high number of assets in and around your plant. And no matter how that we gather the information, it all can go to the same portal with pictures, and also can give you an idea of the lifeline of all the events that we found within that asset along the way. So over time, when you talk about digitalizing the process with your asset health condition, this is exactly what we mean by it. right? This is the way to package it all up to be able to understand how do we now see and how do I know my asset health across the whole plant? And then we can look at it in terms of that way. And I think for me, that is the strategy that we're moving forward with because A is the most cost effective. B, you're utilizing the best technology, but only when you need it. But you've got data to back up why you're doing it.
And it will only,
You know
and
what I mean?
ultimately, you know, putting a Sparrow sensor on is fantastic. It's such a great tool on the majority of machines where nothing's too complex, where we can get that measurement, you know, once a day if we really want to. And it may be that the future, as the plants digitalize further and further, that more of these sensors get deployed, but it will only happen as the price model becomes more and more and more competitive with
Yeah.
portable data
And also,
collection.
it will only happen when everybody on the plant has done the reliability standards and understood how everything can fail and have put a good planned maintenance system in place to counteract the
For
fact that
things
we're not there.
Exactly.
And that, for me, is going to take a hell of a lot longer, right, than the latter, because I think
Yeah.
technology is getting cheaper. And I do think it is going to,
The
you know,
technology
multiply.
will get cheaper before the
The,
reliability is
Because the
embedded.
culture, remember, technology, we've seen this, mate, through our whole journey within this business growth, right? The technology moves at a rapid pace, but the culture and the understanding and the reason that we're doing is not moving. This is why we're here. This is why we do this podcast all the time, to raise the awareness of why we're doing it. Let's not just do it. Let's understand the reasons why. Let's have a discussion. Let's have a chat about it. Let's understand why. Let's have a look at the whole purpose. Remember, we're only looking at just one small part of the pie here. We're looking at a vibration analysis strategy. We're not even talking about thermal imaging, talking about oil sampling, talking about all these other things that as well will be identified in the Famika stuff. Remember, this is just us coming in and almost looking at that one side. There's a lot more we can and will help with off the back of it, 100%. We've just gone deep into one subject, if that makes sense as well. So remember, there's a wider scope than all of just vibration analysis. You talk about, you know, a CM strategy or a condition-based maintenance strategy. Yeah, it's great to understand there's a defect in a gearbox, but that's too late.
It doesn't
It's too
improve
late. You're not improving the You're detecting the issue, but I can guarantee if you're seeing wear within a gearbox, well, the gearbox is worn. It's too late. We need to understand the oil, and that's a whole nother story for. But again, that taps then into proactive maintenance, which is a completely different thing. Right now, we're detecting issues. The detect model that we're looking at now, right? The improved bit is a completely different culture conversation. Do you know what I mean? And I don't know if the industry's quite ready for that yet. Do you know what I mean? Because when we're talking about proactive maintenance, well, if we're not even detecting the issues that happen and you're in the reactive state, then we're not ready for proactive maintenance quite yet. We've got to get to us to a position where
we're not reacting.
we're not reacting. So remember, if we're reacting, we're not proactive. So the first aim is to get out of reactivity first, so then we can focus on the next stage. But I think that opens up a new line for the next podcast to talk about proactive maintenance. What are the tasks that will prevent failure? Do you know what I mean? And improve
Maybe the
reliability.
tasks that are often done whilst we're collecting portable data collection.
Yeah, definitely. Might be another really cool podcast to go over because I think we've covered today really nicely with kind of vibration analysis and strategy, right? And if anyone wants to have a chat about us, because we can come in,
Demoing any of this.
doesn't matter how big your site is, how small your site is, right? We've got demo kits on all three of them systems as well to show you what the data looks like when it comes in. We've got trial versions of Nest as well, Nest Vision, so you can see how it looks like for your assets to be in that portal. And as well, we could even do a little bit for it. We could take 3 or 4 assets with a bit of with handheld, put one on the Sparrow, put one on the VX, show you what it looks like so you can see the whole strategy. But more importantly, we'll look at all of them assets and we'll devise a strategy of what is the best strategy to move forward with. And we can do that quite quickly. So, guys, thank you for tuning in. Really great discussion today. Got me amped up and ready to go. I'm actually got a meeting now to go talk about some sparrows. So I'm ready. I'm ready to go. So, guys, thank you for tuning in. And yeah, we'll see you on the next one.